this lesson is going to be about parabolas again. This time we're going to talk about the third form, which is called intercept form. We are going to work with this form to find the x-intercepts, also sometimes called the roots of a parabola that is written in intercept form. We are also going to then find the vertex and the axis of symmetry of that parabola. And then we're going to look at an equation that's written in standard form, and we're going to rewrite it into intercept form so that we can find all of those things. First thing to know is, what is intercept form? Intercept form is given in the format y equals a times quantity x minus p times quantity x minus q. P and q are numbers, so it might be x minus 5 and x minus 2. P0 and Q0 are the two x-intercepts of the graph. And then A, of course, still determines if the graph opens up or down. So we have this intercept form here, y equals x minus 5 and x plus 2. So you can see that P and Q are 5 and negative 2. Now let me pause for a second. Why is it negative 2? Because remember that this is supposed to be x minus a number. X minus negative 2 is what gives us x plus 2. So the rule of thumb kind of when working with this is always take the opposite of what's in the parentheses. That's been true with vertex form. That's true of a lot of different things when we're factoring, etc. Same idea here. Take the opposite of what's in the parentheses, okay? So our roots for this one would be at x equals 5 and at x equals negative 2, which means that they're at the points 5, 0, and negative 2, 0. That's where the graph is going to cross the x-axis at both of those points. The axis of symmetry is going to be halfway between them. So I find it helpful sometimes to look at the graph to really kind of help us visualize this. Here's the graph, and I've got the two intercepts on there. The axis of symmetry, as well as the vertex, right, is going to be halfway between the two. So you can see the vertex is down here. It's a little hard to tell exactly where that is. But anyways, so the easiest thing to do kind of is just to count, okay? And if we count into the middle, we can see that halfway between 5 and negative 2 is going to be 1.5. So the axis of symmetry is at x equals 1.5. Or you could also say that that was 3 over 2. It doesn't really matter how you write it. And then to find this negative 12.25 of the vertex, you simply take the x coordinate, the 1.5, and you plug it back in. So you'd say 1.5 minus 5 times 1.5 plus 2. Well, here you get negative 3.5, and here you get positive 3.5. And then if you multiply those out, you get negative 12.25, which is where that y coordinate comes from for the vertex. So first thing you're doing is finding the roots from the equation. They're right there. Take the opposite of the parentheses. The axis of symmetry is halfway between them, so you can count into the middle and then plug that value that you got for axis of symmetry into the equation for both x's and solve to find y. Let's try another one. So here we have this intercept form here. First thing we want to do is find the roots. So our roots are going to be at x equals 1 and at x equals negative 2, which means that we have a point at 1, 0 and at negative 2, 0. Now let's find the axis of symmetry, which is going to be halfway between the two. So halfway between 1 and negative 2, if you kind of count in or think of a number line, if that helps. All right. So we've got, here's 0, there's 1, 1, and negative 2. If we count in, go 1, we're going to get halfway between negative 1 and 0, which means that the axis of symmetry is at x equals negative 1/2 or 0.5. Does not matter how you write it, okay? So to find the vertex, we're now going to take that negative 1/2, which is our x, we're going to plug it into the equation to find y. So we're going to say 4 times negative 1/2 minus 1 times negative 1/2 plus 2. Now you do have to keep that 4 there. That's part of the equation, and that's going to come into play when we're finding our y, because remember, this whole thing is what y is equal to. So now we're going to have 4, and then negative 1/2 and negative 1 is negative 1.5. or negative 1.5, or negative 3 over 2. I think I'm going to make that negative 3 over 2. So that's a little bit easier to do. And then negative 1/2 plus 2 is positive 3 over 2. Notice that these are the same. That should happen because a parabola is symmetric. That means that the roots are going to be the same distance from that center point, which means that your two parentheses are always going to be the same number, just opposites. Okay? So, sorry, I'm flipping my screen on accident. 4 times negative 3/2 times 3/2 is negative 9. Feel free to grab a calculator and check my math there. So you get y equals negative 9, which means that our vertex is at negative 1/2, negative 9. So we have found our intercept form here. Oh, the other thing I wanted to talk about is A. So A is positive, which means that the graph opens up and our vertex is going to be a minimum. So the graph opens up and we have a minimum at the vertex of negative 1/2, negative 9. And here you can see the graph. Just in case that's kind of helpful to you, you can see that the vertex was at negative 1/2, negative 9 here. Our roots, and then the axis of symmetry, I didn't draw it in, would be halfway between. Okay, let's try another one. Go ahead and pause the video, try this one out, see what you come up with. Hopefully you figured out that x is equal to negative 5 and positive 5. So then we have intercepts or roots at negative 5, 0 and at positive 5, 0. And the axis of symmetry then is halfway between them. This one's a little bit easy because 0 is halfway between the two, which means that the vertex is at 0 something. So let's plug 0 into the equation to figure it out. So we have negative, and then 0 plus 5, and then 0 minus 5, which gives us negative times 5 times negative 5, which is 25. So the vertex is at 0, 25. We know that this graph is going to open down because A is negative. Technically, it's negative 1. So the graph is going to open down, and we have a maximum at 0, 25, which is exactly what this graph shows. We've got our two roots at negative 5, 0 and 5, 0. We've got our vertex at 0, 25, and the graph opens down. Now, what if we have an equation that is not in intercept form? It's in standard form. How do we figure this out? Well, pretty easy. You factor it, okay? So we're going to factor the expression here. Now, this says factor out the coefficient. If there is a number in front of the x squared that is not 1, you do have to factor that out first, and we'll get to that. This one is pretty straightforward. We're just going to factor this into its parts. So remember, factoring means we're looking for what multiplies to make 5 and adds to be 6. Well, obviously that would be 5 and 1, okay? So we have x plus 5 and then x plus 1. Oops. Which means that our intercepts are at negative 5, negative 1, et cetera, et cetera, et cetera. We're not going to go into all of that right now. We're just focusing on converting right now. So now this is in an intercept form. I can do all the things with it. So let's work through this one. We're going to factor out the coefficient, which in this case is 1, so we don't have anything to factor out. We're going to move on to the next step, and we're going to factor the expression. So what multiplies to make 15 and subtracts to make 2? Well, let's think about the factors of 15. Our choices are 1 and 15 or 3 and 5. Well, 3 and 5 make 2 if we subtract them. So then the question is, where do the signs go? Do we want to make it positive 3 minus 5, or do we want to make it positive 5 minus 3? Well, we need a negative 2, which means that we need a positive 3 minus 5. Okay? From here, again, this is intercept form. We can find our roots. We can find our axis of symmetry, all of those things that we know how to do. Let's try one more, because here, notice there is a coefficient this time. So we're going to start by factoring that 2 out of everything, which means that we have x squared minus x minus 12. Now we're going to factor what's in the parentheses down into the 2 roots so that we can do this. So we're going to figure out what multiplies to make 12, and subtracts to make -1. Well, 3 times 4 makes 12, and if we take 3 minus 4, we get -1. So notice this one is a little bit different in that we have that number out front. That's our A. A is not 1 this time. So we just factor that 2 out of all of the terms, leaving us with 2 divided by 2 is 1, 24 divided by 2 is 12, and then we factored like normal. Hopefully this is making sense for you, both the working with intercept form as well as factoring from standard form to get it into intercept form. My suggestion would be, now that we've got this one, take it real quick, figure out what the roots are, figure out what the axis of symmetry is, and then start the video again to see that. So hopefully you figured out that x is -3 and 4, which means that we have x-intercepts at 4, 0 and -3, 0, which means that our axis of symmetry is halfway between them. Halfway between 4 and -3 would be at +1/2. So x is going to equal 1/2, which we're then going to plug in to get the vertex. So if you plug 1/2 in for the x's, I like to actually plug it in right here. However, you could plug it back into the original if you really wanted to. But 1/2 plus 3 is 3.5, and 1/2 minus 4 is -3.5. And when we multiply those, we get -12.25 times the 2 that is out front, which is -24.5. There we go. We know that this is opening up, and we have a minimum because that A is positive. So hopefully this is making sense for you. You're understanding intercept form. You can find the intercepts or the roots. You can also convert from standard into intercept form to find those things. Have fun with your